Let's see how to do multiple regression in Excel using using the data analysis plugin. I've got the data set we've been working on here. I like to color code things, so I'm going to color code the y variable, including the label at the top here. So I'm going to highlight all that, and the only color I can think of that starts with y is yellow, so we'll go with that. And I'm going to use the average teacher salary and percent of pupils taking the SAT as my x variables. So I'm going to highlight those. And it's hard to think of a color that starts with X. I'm going to go with X-ray. X-rays are usually black with the bones and stuff showing in white. So Excel doesn't care how you highlight your variables, but it makes it easier when you're planning to do regression. So I'm going to come to the Data tab here and use the Data Analysis plugin. I have a separate video about how to find and add that in. It's got an alphabetical list of tools here, and we want regression. I'm going to hit OK. And I've already got this filled in, but we'll fill it in again. So the Y range is the yellow stuff, and it's important to include the column label right above where the numbers are. So I'm going to highlight that. And the X range is these variables. So I'm going to click here. The quick way to do it is Shift cursor right and then Control Shift cursor down. And then let's look at these check boxes. Did we provide the labels, the words at the top of the column? Yes, we did, because we should pretty much always do that. So we make sure that the labels is checked. Constant is 0. Do we want to set the intercept term to be exactly 0? We hardly ever want to do that. Confidence level for confidence intervals, turns out it will provide 95% anyway, so I usually don't check that. It's usually best to put it in a new worksheet ply. Let me call this teacher salary regression. Do we want to see residuals? Yes, we do, so we make that, we check that. Residual plots and line fit plots, those are usually good. Standardized residuals is too fancy for our class. You should take a linear regression analysis class and you'll learn more about it. And normal probability plots ordinarily are a great idea, but the regression tool here has a major bug in it, and the plots it produces there are worthless, so we're not even going to bother checking it. One quick note, when you're choosing your X range, the X columns have to be right next to each other. You can't have like column D and then column F. All your X variables have to be next to each other. So I'll hit OK there, and it generates a new tab. And let's go explore this tab a little bit. So it gives us our R squared, something called adjusted R squared that we'll talk about later. It gives us this standard error, which is basically this, it's approximately standard deviation of the residuals. So if we wanted to say how good are our predictions, we could say they're off by 33.6 SAT points plus or minus on average. We've got this ANOVA section that we don't have time to deal with in our class. You should again take a linear regression analysis class for that. So I'm going to gray that out so it doesn't distract us. We've got a table of coefficients here, and we've got a table of predicted values and residuals. And we've got these plots. The first two are residual plots, and the second two are the line fit plots. Now, sometimes Excel, particularly on a Mac, will mess up these plots and just give you like a dozen data points, even if you really had 50. And the X values will usually be like 1, 2, 3, 4, 5. I don't know of any workaround for that. It's just a bug. So in the next video, we'll explore this sheet a little bit more.